So welcome to the session on constraints and search. The first talk is given by Markku Laine on finding web layouts by integer programming.
Good afternoon. My name is Markku Laine. I'm a postdoc at Aalto University. And in this talk, I will talk about our latest research work on responsive and personalized web layouts. And this work was done in collaboration with Zhang, Simo Santala, Jussi Jokinen, and Antti Oulasvirta. And it was published previously this year in the Proceedings of ACM on human-computer interaction. So what is responsive web design? According to Wikipedia, responsive web design is an approach to web design that makes web pages render well on different devices. Here is an example of a responsive web page where the layout and the content has been adapted to different screen sizes. As we can see, the viewing experience here is improved compared to a static website, and there is no need for zooming or panning of the website. However, there are still many different challenges with these responsive web designs when we are building this. And the first one is that the designer needs to design multiple layouts for different screen sizes. Also, the developer needs to do additional work by implementing these adaptation rules. The designer, together with the data analyst, needs to decide what are the optimal breakpoints for different device segments. And finally, there is very limited support for personalization. So basically, all these layouts look and feel the same for all different users. With these challenges in mind, we set out to explore how to generate responsive web designs so that they can be personalized for the user and browsing device. And what we came up with was this proposed system called CRWV, short for Computational Responsive Web Design. And here, given an existing web design for the system, along with the optimization objectives and constraints, we are able to generate consistent set of designs for these different target devices. And if we have user interaction data available, then we can also personalize these generated designs for that particular user and the browsing device. Here is an example where we have a static mobile layout on the left-hand side, and we take that one as an input for the system, and the system is able to generate designs for different screen sizes. Here is another example about the personalization. So on the left-hand side, we see different elements that the user is interested in, marked in red. And when we have this information available, then we are able to personalize the layout on different levels for that user so that the elements that the user is interested in become more prominent and also more accessible. And that way, the usability of the layout can be improved. We built this system on top of our previous work called Layout as a Service, LAS. And LAS is, in short, a self-optimizing a platform for self-optimizing web pages, and it also enables objective-level personalization of layouts. And what we did, we extended this platform to support responsive web pages in various different ways that we will next talk about. So the first major extension is about the creation of responsive shapesets. And here we identify the key elements of the layout, and then we simulate each of these elements in different sizes. And based on this simulation, we can then label these elements either as infeasible, non-ideal, or ideal. And these labels are then utilized by the optimizer when it's trying to generate these designs, final designs. The most important feature or extension to our system is layout optimizer. And for this one, we used mixed integer linear programming model. And this method has several different benefits compared to other approaches, such as data-driven methods. For example, it's applicable to a wide range of problems. Also, we don't have to collect any training data for this one. We can also have a good control of the design outputs, and the computational performance is really good. And for this model, we created several objectives. One is for layout similarity, one is for aesthetics, and one is for usability. And some of these are also controllable by the designer or the end user. Here is the optimization process, which consists of 4 different steps. So in the first step, we try to infer what are the most important elements for the user, and then based on that, we can then rearrange the elements. Then we optimize the layout for aesthetics so that we get a good grid layout. Then optimize for the usability, maximizing the visual saliency of the elements and also minimizing the selection time. And finally, we put everything together. And the third and final feature is about web page retargeting. And here, the idea is to adapt the original layout to a new generated layout. And what we do here is we convert the layout from positional layout to flexible grid layout. We do this adaptation also in real time. We need to also generate the navigation bar again, because the original might not support mobile and desktop. And we also do smart image recropping. To summarize, this approach allows automated generation of responsive and personalized web designs, and ensures well-formed grid layouts. We evaluated our approach with 2 different user studies to see how users perceive the quality of these generated layouts. And we conducted the study with end users and designers as well. And both of the studies were done online, and they consisted of multiple screen sizes, and the different layout methods that were in the comparison were the original one made by human designers, then the optimized version, and the masonry as a baseline. Here is an example of the material that we have. We created 4 different websites for this study. And here you can see an example of the different methods, how they look like, or how the same web page can be rendered using different methods. In the first study with end users, we had 86 participants, 53 male and 33 female. And according to the results, our method was able to generate designs that were very close to original ones created by human designers. And they got also higher ratings compared to masonry method. In study 2, we also had designers. We had in this one designers instead of end users, and 64 participants were included in this study. And again, in the results, we can see that our ratings were very close to the original ones and better ones compared to masonry, especially in the larger screen sizes. The take-home message basically from here is that we can generate responsive and personalized web pages, and this way we are able to reduce some of the burden from designers and developers. And in fact, we are at the moment working hard with the professional designers so that we can bring these features and some additional AI-powered design features to their favorite design tools. This concludes my talk. Thank you very much for your attention.
Thank you very much. Questions? Do we have any questions? I have a question. So how do you decide? So let's assume somebody has a browser and then they start making it smaller or bigger. How do you decide at which points does it change? Or is it a decision you can make when the browser is used, or do you have to make that decision beforehand?
Yeah, so we have actually two different ways. We can, the website owner can design, or the designer beforehand, where are the breaking points. Or we can also automatically, in runtime, infer it based on the device the user is using. If it's a mobile phone, for example, you have only two different basically sizes for it. So we can optimize for both of the sizes automatically.
Okay. Any other questions? There is one.
So aside from screen size, some people might also want to change the font size if they, for example, have difficulty reading that. Have you tried something like this also? So where the screen is the same size, but the font is different?
Yeah, basically our method also tries to take into account the font size, so that it's not the same for mobile and desktop. So that is also like increased or decreased based on the target device.
Is it possible to somehow infer dependencies or some kind of relations between the pictures and the text, so that you would be able to keep those close to each other when you reorder the page?
Yeah, that's a very good question, actually. We have done in different projects work related to that. So the designer can define association between different elements and the weights, like how close they need to be, or let's say you have an image and text and the title is linked to the image, so obviously those need to be very close by. So that can be defined pre-hand. But this work, we only try to find the major elements in the layout and reorder those. So basically the context still remains.
Okay, thank you very much.
Thanks.
Once more.